Okay, the next one is that cos button that you see on the calculator. That is pronounced cosine, Cosine, but we'll always abbreviate it as COS for cosine. And just like before, when we talked about the sine ratio, the sine of an angle here, angle C, right, that was opposite divided by hypotenuse, the cosine is a different ratio, and all we're doing this time is we're comparing the adjacent divided by the hypotenuse. So when we have this angle C, the side adjacent to angle C is the side that is touching angle C. Okay, I know the hypotenuse is touching angle C also, but that's always called the hypotenuse. It's the leg of the triangle that is touching the angle, that is adjacent to it, that's next to it. And that's this length right here. Okay? So as we move, I'm going to do something similar. I'm going to move around the x-axis here, all right? The cosine is going to be the adjacent, the length of the adjacent side divided by the hypotenuse. And just like before, in a right triangle, the hypotenuse is always the longest side. Okay? So what I'm going to do is I'm going to start really close inside the, like I'm going to start at a small or a large angle here. Okay, angle C is really steep, right? But 75.9 degrees, okay? And we can see that this is a very small adjacent side. And we can see the hypotenuse is much larger. So if you just think about it, we're comparing the adjacent side to the hypotenuse, the length of the adjacent side to the length of the hypotenuse. This adjacent side, this length, this looks to be about 1, right? This hypotenuse is much larger. So this ratio, the length of the adjacent side divided by the hypotenuse, would probably be a small number because we have a small number, 1, divided by a much larger number. I don't know how large this hypotenuse is. It wouldn't be too difficult, right? Because we can use the Pythagorean theorem. This opposite side is 4, so 4 squared plus 1 squared is 16 plus 1 is 17. This hypotenuse right here is a little bit bigger than 4. It's the square root of 17. 4 squared is 16, 1 squared is 1, 16 plus 1 is 17. So this hypotenuse is the square root of 17, which on the calculator is 4 point something, okay? So we're comparing the adjacent side, 1, in comparison to something a little bit bigger than 4. Well, what is that? What is that ratio? In this particular case, the ratio of the adjacent, because we're doing the cosine now, adjacent to the hypotenuse, this adjacent side right here, this length, it's about 24.4. So if I round, I'll say 24. This adjacent length is 24% as long as the hypotenuse. And that looks about right. It looks like I can fit about, 24% is almost 25%, which is 1 out of 4. 1 out of 4, sound familiar? This adjacent side is 24% as long as the hypotenuse. So now I'm going to start moving this point, and I'm going to move it to the right. So what happens when I move it to the right? Okay. What about when this guy right here is I'm not going to be able to hit 60% exactly, 60 degrees, but I'm trying to. Let's just say this is 60 degrees, 59.9. Okay. When I'm comparing the cosine, when I'm looking at the cosine, I'm comparing the adjacent to the hypotenuse. So in a 60-degree angle, I can't quite get 60 degrees, but just bear with me. When this angle is 60 degrees, the length of the adjacent side is half, 0.5, is half the hypotenuse. And that looks about right. Okay, I can fit 2 of these adjacents on one of those hypotenuse, if that makes sense. I know it's kind of a weird terminology. But in a 60-degree angle, the adjacent side is half as long as the hypotenuse, because those are the 2 sides that we're comparing. And that one's going to show up a lot. So try to remember the cosine of 60 degrees is 1/2. Because, a deeper question here, why is it 1/2? Because the adjacent leg next to this angle is half of the hypotenuse. And what happens when I go out further? really keep going out here. You can see what's going on. As I move along the x-axis and I'm moving to the right, yes, the adjacent side is getting longer. Yes, the hypotenuse is getting longer, but remember, it's a right triangle, so the hypotenuse is always larger than the adjacent side. So if you think about this fraction that's going on, the adjacent divided by the hypotenuse is always bigger. The denominator is always bigger than the numerator, which means your fraction's always going to be less than 1. And as I keep going out, it gets closer and closer to 1, okay? But it never will be. I can do this forever. That angle is going to get smaller and smaller and smaller and smaller, okay? And as this angle gets smaller and smaller and smaller, the length of the adjacent side, it's creeping up on the hypotenuse, but it'll never be quite as long. So how about this guy right here? At 9.46 degrees, okay? The adjacent side is about 98.6%, or almost the entire hypotenuse, okay? Until, you guessed it, if we kept going forever, which we can't, okay? But you can see where this is leading up to. That angle's getting smaller and smaller and smaller. And so what we're going to say is the cosine of 0 degrees is going to be 1. Because if this were 0 degrees, then technically we wouldn't really have a triangle, right? And the hypotenuse would be lying right on top of the adjacent. So they would have the same length. I know that's a little weird if you can visualize that. But what happens when I get closer and closer and closer? Right. What's happening? I'm going to really zoom in here, okay? As I get closer, as this angle gets bigger, 21 degrees, 25 degrees, as this angle gets closer and closer and closer to 90 degrees, right? The hypotenuse is still pretty long, but the adjacent side is getting this adjacent side is getting closer to 0, right? So when we compare the adjacent to the hypotenuse, in our fraction, the adjacent's in the numerator, the hypotenuse is in the denominator. The numerator, or the adjacent side, is getting really small. It's getting closer and closer and closer to 0, right? And you probably remember when you have a fraction and 0 is in the numerator, the fraction's going to be 0. And that's why the cosine of a really steep angle is almost 0. In this case, it's almost 0. And as I keep going and going and going, as I get closer to 90 degrees, I'm going to back away for a second here, that adjacent side is getting smaller and smaller and smaller. And the hypotenuse is getting closer and closer to 4. So we're getting a fraction whose numerator is getting closer to 0, the adjacent side, divided by the hypotenuse, the denominator, which is getting closer to 4. So you're getting a number that's getting closer and closer to 0 divided by 4, which of course is 0, which is why the cosine here is almost 0. Until we hit 90 degrees. Huh? The cosine of what? We don't really have a triangle, do we? But that adjacent side is now 0. We don't even have a side. The length is 0. So moral of the story is the cosine compares the adjacent side of a triangle. Whatever angle I'm looking at, I'm looking at angle C right here. The leg touching angle C is the adjacent it's next to. And the cosine ratio compares the adjacent to the hypotenuse. So remember that the sine is opposite over hypotenuse. The cosine is adjacent over hypotenuse.